Hello, it's going to be part 23 of our game making tutorial. Have I got fraps showing a frame counter in the corner? That's not right, let's not do that. Okay, let's go. And this is going to be I want to do a part that's just about debugging, and so we might not actually even touch our main project. I just want to talk about it and explain how I go about it and some things I've learned about it. And the key to it, I think, is basically the reason it's important, the reason it's worth a whole episode, excuse me, is that it's what I spend most of my time doing. Like, Gunpoint took 3 years of my spare time, and if every time something didn't work the way I intended it, I instantly knew why and was able to go back into the code and correct it, then it probably would have taken 1 year. It's probably about 2/3 of my time is spent chasing down problems that I don't understand yet. And past a certain level of complexity, it gets to the point where, for me at least, everything breaks. Like, almost nothing works first time. I'm getting to be a better programmer, but I'm still not at the point where, you know, most things work first time. Every now and then it happens, and it's a wonderful, magical feeling. But once you've got a lot of code you're working with, you know, in theory, you want to be structuring a code so, like, each bit doesn't depend on all the other bits. And we can do some work to make that happen, but in practice, it's kind of, that's more like the platonic ideal of code, and really what ends up happening in a game is, like, the things have to in some way interact with each other, and any way they can interact with each other is going to cause some kind of problems, and things are going to get more complex as you go along, and you are going to have more problems, and you can spend a long time trying to solve them. And the key is that you shouldn't try and solve them. If you think about how, if you watch like a detective show, and you think about how they go about solving the case, every bug is a mystery, and every bug can be solved with one tiny piece of information. It's always a piece of information you express in a single sentence, where if I could go back in time and tell myself that, my previous self would be able to instantly fix it. It's never difficult to fix a bug, it's always difficult to find out what it is. Or at least, whenever a bug is difficult, the challenge is finding out what is actually happening, what is going wrong. And as soon as you know what's going wrong, it's literally almost always just like, oh, instead of less than, it should be greater than. Or instead of +1, it should be not +1. Or this line should be taken out, or something like that. And so fixing bugs is trivial, understanding bugs is really difficult. And so, back to the detective analogy, they don't spend the whole episode trying to get a conviction, unless it's Law and Order. They spend 90% of their time not even looking for evidence necessarily, but looking for who they should be looking at. You can't get a conviction until you know who you're trying to convict. And so with bugs, you spend most of your time just trying to find what the culprit is. What suspect should you be looking at? What line of code is doing this? And until you know that, it's almost impossible to see what's wrong with any of it. I don't know why I'm coughing so much today. So you can have a situation where the bug must be in one of these 3 different bits of code, and when you don't know which one is actually causing it, you can look at them again and again and again and again and again, and they always look perfectly right. It has to be that, it has to be that, that has to be right, that's definitely right, that's definitely right, that's definitely doing. And then if you run like one little diagnostic thing that can actually tell you which one of those 3 things is wrong, if you can just in some way eliminate those 2 things and just say those 2 things are definitely not the problem, it must be in this 3rd one, as soon as you do that, you can see the mistake. It just, like magic, it's suddenly, oh, it's that. So I wanted to talk through like a real example of this, because I didn't want to contrive a bug and then pretend to hunt for it whilst secretly knowing the answer all along. So instead we're going to look at the bug I fixed this morning in heat signature. And before we go any further, I want to apologise for the fan noise. I know that's been a problem throughout this whole series, and it gets worse and worse throughout one episode because my laptop just gets hotter and hotter as it's recording. And the reason you hear it is that we are recording this through the mic built into the laptop, so the mic is actually in the chassis, and that's why it picks up the fan noise worse than it normally would. I have spent 2.5 hours today trying to find a workaround for this, because if I had an external mic it would be fine, because it wouldn't pick up the fan noise so much. But I'm running Windows under Boot Camp on a MacBook Air, and the jack for mics just flat out doesn't work. I've installed so many drivers, I've tried so hard to fix this, I can't do it, you're just going to have to put up with it, sorry. And we'll definitely have some fan noise today, because heat signature is a much more demanding game than our test project. And because I'm recording it, it's probably going to run like shit as well. But anyway, this code that's on screen is something I'm going to talk through later, which is my tool for debugging, which I've written myself, and which I'll, when you've got the code here, you can look at it, but also I will probably talk you through how it works. And the problem I was having was, in heat signature, you flying around a galaxy, there's space stations in the galaxy, and once you get close to one, they would sometimes disappear. Or rather, so if you were very close to one, they wouldn't disappear, but within a certain radius, they would start to disappear. And it was only when you're zoomed in. And so it's weird, but I had a pretty good idea what it was, because to save a certain amount of processing power, when a space station is way off the screen, it just stops drawing it, stops thinking about it, stops simulating all kinds of things about it. Right, so I'm actually re-recording these bits because I forgot that if something goes full screen, OBS doesn't record it. And I know there's a solution to that problem, but I haven't done it. And so we lost all of the sections in this where I actually play the game. So I'm re-recording. Anyway, this was just to illustrate the problem. These are space stations. If I zoom out, each one of those dots is a space station. And the issue with them is, this is just placeholder art, obviously. It's just like we want to get a sense of the scale of them, and also the actual bit in the center is also placeholder. That's my placeholder. And although it's placeholder art, we'd still like it to display even when you zoom in. And it doesn't. It doesn't display when you zoom in until you get to a certain threshold, and then it does. And then we go away again, it vanishes again. Which is weird. That makes a certain amount of sense. I thought I knew what this bug was, because it tends to disappear when the middle of the space station is off the screen. And so my code for disabling things when they're off the screen was being too enthusiastic. Like, before it was fully off the screen, it was disabling it. And I had just put in a new bit of code that was supposed to fix this, where, if we look at the draw event for this space station, it says, if you're zoomed in enough that you're going to see the station at all, i.e. we're not in map mode, then this is the bit of code that we're looking at. This is the bit of code that's actually doing something. And what it says is, if we are anywhere near the screen, including our radius being the kind of size of the thing, then draw these 4 quarters of the space station. That's what we're seeing. And that is what is not happening when you are zoomed in and you start to go a little bit further away from the centre of the station. So the key has got to be in here. It's got to be something to do with this detecting when we're on screen. And what this does, if we open it up, is... Oh, this is actually my simplified version. This is good. So at this point in the solving this bug, I had already simplified this code, because this code was checking if are we off the left-hand side of the screen by a certain amount, are we off the right-hand side of the screen by a certain amount or more, are we off the top side of the screen by a certain amount, or are we off the bottom by a certain amount. And in each case, the certain amount it was checking against was they would check against the actual edge of the screen, then it would add on a whole width of the screen as well, and then it would also add on its own radius. So if you're 1,000 pixels wide, you have a radius for 1,000 pixels, and you're 1,000 pixels off the edge of the screen, we'll count you as being on the screen, because there's a small chance that maybe if the view is rotated, a pixel of you should be on screen. So it's very, very safe, it's very conservative. And I simplified it to this, which is just saying, if the difference between us and the centre of the screen is less than our radius plus the width of the view, then show us. If we're also on it vertically, and the vertical equivalent is our y-coordinate, the distance between our y-coordinate and the centre of the screen is that less than our radius plus the height of the screen. And that's, again, more generous than it needs to be. You only actually need half of the width of the screen and half of the height, but we are not trying to get this precisely right. It doesn't matter if we simulate some things that are slightly off screen, but it matters a lot if we simulate everything at once. That's bad, too slow. And it matters a lot if something should be on screen and we're not showing it. So I looked at this again and again, and I couldn't see anything wrong with this code. I rewrote this code to make it better. And so I thought, well, it's got to be the radius. The radius is not getting set right. So then I look in the create event where we set the radius. Here's what it is. Radius equals 2048 times station scale, which is 4, times 2, which is vast. This is absurdly huge. This is, again, I've been much more generous than I need to be. Is actually, each of those segments is 2048, and we do show them at quadruple size. So it's like 8,000 something. But then we're multiplying it by 2 just to be ultra sure that even at diagonals, even at weird angles, it's not going to be too small. So the radius seems absolutely right. And then the only other thing I could think of is maybe is some other function later on changing our radius. I looked for that, couldn't find anything like that. So all this code that's happening, I've looked at it all, I've checked it all, and nothing's going wrong. It's all perfectly right code. And this is where I start to lose my mind. This is where I start to think, it's just fucking GameMaker. GameMaker's just gone crazy. It's not my fault. It's the fucking GameMaker's fault. And it isn't. Because something else is happening. And again, it's not... Once you know where to look, it's so easy to fix. But I didn't know where to look. Or I thought I knew where to look, and I was looking at this, and this is correct. It's absolutely correct. And so this, when I should have done this sooner, but I hit the point of confusion and frustration where I know the next thing I need to do is not try and fix anything, not try and find the problem, but make it tell me what's going on. Force it to say, exactly what are you doing? This thing where I'm comparing my distance from the screen to this value of radius. And I've experimented with the possibility that radius could be wrong, but even if you multiply radius by 200, so it's millions of pixels, hundreds of thousands of pixels, then it's still, not only does the problem still happen, but it still happens at the exact same point, the exact point you would expect it to happen if the radius was 0. So how is that possible? How can the radius be 0? Even if the radius was 0, we're adding on the whole width of the view as well, so that should be having an effect. And so I had to stop trying to understand it just with mental analysis and actually make it tell me something. And this is where debug log comes in. So this is a script I've written myself. GameMaker does have a debug mode. If you click this red arrow, then when it runs the game, it will have a separate window that you can kind of type in things and say, hey, tell me what the value of this variable is this time. I haven't found it that useful because I find it very hard to get the game to tell me just what this object's properties are, or to tell me some specific thing at some certain time. And also I want to be able to kind of see things in real time and then review like a log of what happened, that kind of stuff. And also it just doesn't work sometimes. Like about half the time I've tried to use it, I'll type in a variable I want it to check and it just says, no, I can't evaluate that, even when it's the most basic property. So I'm sure there's a reason for that. I'm sure there's something I'm missing there, but I don't want to spend my life debugging someone else's debugger. So I just made my own. So mine is this thing called debug log, and I'll explain how the code works, but first I'll show you how you use it. And I'll give you this code so you can actually put it in your own projects. I don't know if we'll actually take the trouble to implement it into the current example project. Like, I don't know if I'll go through that today, because that's not very interesting, and I feel like you could just probably copy and paste the code. You don't really need to understand what it's doing, because this isn't the lesson. The lesson is what you do with it. So in the station code, this thing that I think is going wrong, I need it to tell me what's going on. We're supposed to be comparing these two values, this ABS camera X and radius plus HV, whatever. That's the comparison it's doing. And sometimes it's passing it, and sometimes it's not. And so what I want to write is something like debug log. This is telling it to output some piece of information. So you could put in a thing saying like, oh man, my keyboard's changed nationalities. Thanks, keyboard. This is a side effect of messing around with all the driver stuff for microphones this morning. I could put in something like here that says debug log, we are being drawn, and then the point of this is it will output that onto the screen whenever it's being drawn, every step that it's being drawn, so we'll be able to see whether it is or whether it isn't. That's not that useful at the moment, but also the Unity has a function called debug log which works exactly like this, but the annoying thing about Unity is that it's global. So if I put this debug log thing in here, and it's printing every time you're near a station, it's telling you that you're near a station, then when I next want to solve a different problem, I have to remember to go back and delete this debug log and take it out, because otherwise it will be filling up the screen with garbage that I don't care about anymore. So every time you diagnose something, you have to remove all your diagnostic tools after you've finished, before you diagnose anything else. So for my own system, I've given it a channel variable. So as well as saying what you want to log, we say, we give it a channel name for this problem. So this problem is to do with drawing stations. Typing is hard. So I've given it a name, drawing stations. That's our channel name. And then I also want to tell debug log to listen on that channel. So every time we report something that's relevant to this problem, we'll put it on the drawing stations channel, and debug log itself should only listen, for now, to things that are reported to the drawing stations channel. If you don't understand that, don't worry about it. It's an advanced feature of my debug logging system. It's not really relevant to the problem. But the long and the short of it is I get to say, only listen to drawing stations problems. And the drawing station things I want to report are, I don't want to say that because that's not that interesting, but let's report what is our... If we go back into this function, here's one of the values we're interested in. Let's have you actually report that. So in fact, let's keep it simple and just... will we keep it simple? No. We're going to keep it complicated. So that says, print these words on screen, and then also add on the actual value of those, like add those things up and then report the actual number, and show those next to each other on the screen. So that will tell us that value, and then the other value we're comparing it against, we'll just do x's for now, is radius plus view w view. And so again, we put that in quote marks because we want it to show that, and then we actually add it up and report that value. And this will only happen while the station's on screen. And that's actually what we want, even though this means the debug log will stop working once the station disappears. What I was trying to investigate here was these values. If you're saying that our the difference in our x value is greater than this radius thing, and I've already established that the radius thing is enormous, it's a huge value, then how can you explain that? Explain that to me, game. How can you possibly say that's true? So kind of bug hunting is about like leaving the bug nowhere to hide. If it's acting as if these two values have gone out of whack in some way that makes no sense to me, I want it to damn well tell me exactly when they go out of whack. When does it go out of whack, and what are they before it goes out of whack? And like, let me see that change in real time. And then when you can see that, very often the answer becomes incredibly clear. So this should be all we need. We could do the y values as well, but for now let's just keep it simple. So every frame is going to report both these things, and we'll see that scrolling past on screen, and that will give us a clue as to what's really going on. Alright, so here's another station, and if we turn on debug mode, then we see a bunch of numbers flying past, which are, some of them are too fast to read, but you can see that radius plus view w view is 66,000. And right now our distance to the station is like 15,000 roughly. And let's see what happens if we go closer. It gets lower, but it's not in any danger of ever going over 66,000, right? And then if we zoom in, the radius one gets a bit smaller. Now it's 29,000. Zoom in again, and it stays at 29,000. Oh no, it's frozen because the station disappeared. Right, but now let's get close enough for it to appear. Right, when it appears, we look at our readouts again. Our distance is about 4,000, and the radius figure is 20,000. 20,000! 4,000 is nowhere near greater than 20,000. As we get closer, our distance goes down, as we'd expect. As we get further away, it goes up, it goes up, it goes up. 4,000, 4,500, 5,000, 5.7,000, and it vanishes. It vanishes at the moment. Because this debug log thing stops logging at the time that the station disappears, it only logs while a station is actually being seen, we get the exact moment that it vanished. The exact threshold at which our drawing code stops triggering. And it stops triggering when it's 5,000 on the distance and 20,000 on the radius, which makes no goddamn sense, because 5,000 is not greater than 20,000. It's nowhere near greater than 20,000. And if you wanted to be more thorough, we could go back and do the y values, but this tells us something really important. Something weird is going on here, because our x value, like, neither of our values would have changed dramatically at that point, right? So something else is happening. So, this is what often happens, is you're thinking, how can you be doing this? 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 And then you make it tell you, and you realise it's not doing that. The value is not going out of whack. This assumption that we made, that this comparison was failing, is actually an erroneous assumption. We've been looking at this again and again and again and trying to see what's wrong with that code, and there's nothing wrong with that code. That code is perfect. And as soon as you know that, you start to realise, oh, we have to step way back from this. We have to close this draw event. It's not going to do the draw event at all. So something in there is not executing at all. So the draw event itself is probably not executing. And there are, if ever you have something that's not displaying, there are a bunch of different things you can look for. One of them, most common one, is this visible box. Is that checked? Is visibility checked? It is checked in this case, but could there be a bit of code that's disabling visibility? Maybe there is. Maybe you remember writing such a thing. I do. But actually, no, I'd forgotten that. So I have written something like that, but I've forgotten about it. The other thing that could be preventing something from drawing is if you've given it a draw event like this, If you don't give it a draw event, it'll always draw this sprite, dust2. If you do give it a draw event, it's going to do whatever the draw event says. So if you've left out, if we didn't have this draw this sprite normally thing, then it would draw nothing. So it wouldn't draw the standard sprite. It would assume because we set up a draw event, we want it to ignore the default draw behavior and specify our own. And if you fail to specify your own, it'll end up being invisible. So that's two ways. Third way could be it's drawing, but it's drawing way off screen. I think we've established that can't happen. It could be it's drawing, but alpha is set to 0, so it's fully transparent. This is not the problem in our case, but I'm just going through a bunch of different things you can think about if something is ever invisible. But let's get to what's happening in our case. The clue was, firstly, it's nothing to do with the draw event we're looking at. All that code that we had was perfect. But the behavior we're seeing is just like that code. It's like the old version of that code. Before we added that radius thing in, ages ago I had that same code, but without the radius added in. So that means that regardless of the thing's radius, it would be disappearing when on our screen. But you would think that code would be in the draw event, and it's not. We're using the good new function. We verified that that is the new function. So we have to look elsewhere. It's not in the draw event, visible is checked, something else is changing something that's preventing the draw event from even executing in the first place. And this is so often the solution. The solution is just not in the code you're looking for, it's somewhere else. But you would have no way of knowing how to look in that place until you've seen what's happening. As soon as you see what's happening, you eliminate something from your queries and then you focus your attention somewhere else. And as soon as I looked in the step event here, I realized we have this check for if is anywhere on screen, if we're anywhere near screen. That's the old version of this thing. It has no mention of the radius. It just compares my X and Y to the edge of the screen. And that's exactly the behavior we're seeing. When you go off screen, when the center of it goes off screen, it vanishes, even though you would think it would wait until it gets to the edge of the actual space station. And here's the solution. At some point I decided it would be better for the step event to handle whether the thing is visible or not, and that's where I put the old version of the function, and when this fails, we go to the else thing, and it says visible equals false. And if visible is false, the draw event doesn't execute at all. So it doesn't matter what the checks are in the draw event. It's not even going to run them. So that was the culprit, basically. And as it happens, my idea of putting this code in the step event was a good one, because draw is slower than step, and so I ended up moving all of this code into the step event, restructuring it so all the draw event does is just draw, and the whole thing worked. So that's the solution. The method, like I say, I don't think I'm going to actually add this debug log into our sample project, but if you want to understand how it works, there are 3 different parts to it. And there's an initialize script, a log script, and a draw script. So the initialize script, all that does is set up a bunch of variables. I don't think I need to talk through those just yet. And then when we tell something to log a variable, we could just do something like, if we just tell it to log that value, the ABS camera thingy, then we're passing that value and a channel. And when we pass that to the function, it all runs off this one object, the camera, which is kind of, you remember in our project we have an object called the game. I don't have one of those in Heat Signature, so I use the camera for that kind of thing. It's the central single thing, there's only ever one of it, it's always there, we can always rely on it. And then every time you call this function, every time you log something, it sets the channel to whatever you set the channel to be. That's just a constant that we can change whenever we want. Then it takes the string of whatever we submitted. So we submitted that value of how far are we from the screen. Whatever that number is, it takes the string version of that because we're going to be showing it on screen, and if you want to show something, it has to be in text format, and that's what string means. It just means turn this into text. And then here's a check that says if the channel that you've submitted to us, if the channel you're reporting on is the channel we've set that we're listening to at the moment, here's where we define. Let's write that. Define what channel we're listening to. Turn what we were given into text, and then if the channel you're reporting on is the channel we're listening to, and logging is not paused. I've also got a special all channel in there for if we ever want to have a thing that's logged no matter what we're listening to. I don't think that's actually that useful. So if we're listening to the right channel, then we do one more check to say, is the thing we're logging the same as the thing we just logged? Because if you're monitoring like someone's position, and visually the bug you're trying to solve is this person keeps like jumping out of phase or something, and they go back to where they were. If you log their position every frame, let's say their position is x equals 20, then x equals 20 is going to fill up the screen really quickly. It's going to say x equals 20 60 times a second. And then when you're watching it and the player jumps out of sync and goes to x equals whatever, that might be the value you want to know. You want to know, how is this changing? Is it increasing like smoothly, or is it increasing one big jump? How much is it increasing by? Maybe we could look for that figure somewhere. The problem is, after they jump back, the x equals 20s will push the previous thing off screen. So you want, you could pause logging at that point and try and analyze it there, like have some kind of check for detecting that. But I've had bugs where it's so hard to actually to write a bit of code that will detect when the bug is happening. Like if you could do that, you could probably just fix the bug. So what you often want to do is just say, if we're getting the same report again and again and again, don't ignore it, by all means update it, but the line will just say x equals 20 times 60 times 61 times 62 times 63 times 64. So each time it logs the same line as last time, it's just going to add an increment to that one line, and it won't scroll off other things off screen. So all you end up with on screen is just the anomalous data, or stuff that has changed. So each time we get that string, this thing that we defined up here, we check, is that the last thing we logged as well? If it is, then we just increase this count for how many times has it been reported, and we add on to the end of the string times 64, times 65, times 66, however many repetitions we've had, plus 1. And if it's not, then repeated line count goes back to 0, so the next time we report something we won't think we're repeating it. And this is the key bit, I guess. Note that I'm not repeating anything, then add the string to our array. So we have this running array called debug text, and the latest index of it is debug count, and then we set that to be our string, and then increase that count. So debug count is how many lines are in our debug log in total. So when it first starts up, it will be 0, and when we first log our first line, it will go to 1, and each time we report something, we take whatever the current value of it is, make that entry be the new line, and then we increase it, which is just how you add to an array. We kind of went through that in the inventory part. And then either way, whether it was the same one or whether it wasn't, we set the last line to be remember this line so we can tell if it's repeated next step. So hopefully that all makes sense. And that's all the actual functional business of it. And then the only other thing that happens is on that camera event, camera objects draw event, we have this which just says set up how we want to draw the debug text, and all of that is just font stuff. And then this says starting. How does it work? Oh yeah, let's just like figure out what the lowest. Let's just say figure out where the bottom of the screen is. Go through our array of debug reports, starting at 0. Go through our array of debug reports starting at 0, and then until we hit the number of lines we've reported in total, or the debug max. Debug max is going to be how many lines we want to show on the screen at once. You don't want it to display thousands and thousands of lines, because even if they safely scroll off screen, we don't see them. Now the work of displaying those lines is still being done by the code, and that can slow the game down, because you're reporting 60 of these a second at least, and so that gets big quickly. And then in the array, just for each entry, draw it. And the position we draw it at is the only tricky part, which is this bit here. So what we draw is just, do we draw them in reverse order somehow? Yes. Yes. We want to draw the oldest one first. Do we? Can't remember how this works, I coded it ages ago. So the position says start at the bottom and then move us up by I times 20. I is the count, so we start at 0 and we go all the way up to debug count. And for each one of those, we want to draw ourselves the higher our I value is, the further up the screen we want to go. We start at the bottom, which is the maximum Y value, and then we reduce our Y value for each one of these that we do. So we start at the bottom, drawing the latest thing, and then, so the very latest thing will be debug count minus 1, because debug count, if we've had one thing reported, debug count will be 1, and the index of the one thing will be 0. So we want debug count minus 1, which it would be if I was 0, you'd add 1 to it, and then you have debug count minus 1. And then if there was like 10 of them, then the next time through we would go a little bit above and we'd draw the previous entry in the debug log, because we want the latest thing to be at the bottom, and we want to always show the latest thing, and then we want to show as many of the other recent things as possible. So it doesn't really matter if you don't understand that. Here's all the code. I'm not sure how should I give it to you? I mean, you can just write it out from looking at this. Maybe I'll just, like, next time we do an episode, I'll copy and paste this code into our project, because it's pretty simple to get it working. We'll just replace, every time we say "oh camera," we'll just say "oh game" instead, and that should work. So yeah, that's my advice on debugging, and hopefully an illustration of how I go about it, and a tool that you can use for doing it. To recap, the key is don't try and solve the problem, try and understand the problem. And if you can't understand the problem, make it show you what's happening, make it visualize what's happening. Sometimes I'll have it draw lines between different objects, like even lines that you would never want to actually be shown to the player, but like if this enemy is saying that he's too far from the module that he was spawned in, then have him draw a line from his position to the module he was spawned in, so you know which one he's talking about. So each individual enemy will be showing you, I think I came from this module. And sometimes you'll see those lines go to the wrong place, or you'll see them go into space, or you'll see them go nowhere. And that's interesting. So yeah, make it show you what's happening, and until you understand it, don't try and solve it. Just keep trying to understand it. Keep adding more debug readouts, keep adding more debug logging, keep adding more weird lines on the screen, keep having it draw crazy sprites that shouldn't be there, just to make sure that the thing isn't failing because the sprite is actually transparent, or the sprite is set to null, or the sprite is too small, or those kinds of things. Keep eliminating possibilities, keep trying to narrow it down, and once you get to that one little nugget of information, that one sentence thing, in our case with the station thing, the one sentence solution was, in the step event, you're running the old script. And if someone had said that to me, I would have gone, oh shit, yes, of course, I know exactly how to fix this, and just delete that and it's fixed. So keep looking for that one thing, and once you know exactly where to look, once you know exactly what bit of code is failing, it's almost always obvious. It's almost always, oh, that should be a less than, that should be a greater than, whatever. So actually we are going to put this debug log system into our game, because it feels neater to kind of keep it all the things I'm teaching you into one project. And also that recording problem meant that this episode has taken a lot of work now. And so if we're going to put a lot of work into something, I would like it to actually be complete. So I've saved out these scripts. I don't know if we need to go through and actually write them line by line, so probably just copy and paste them in. So it's going to be, we're going to use our game object to handle it, rather than in heat signature it's a camera object. Here we're going to use a game object. So we are just going to, we'll put the initialize script in its create event, and maybe we'll create a folder for this actually, debug log. And then in that debug log folder, we'll create a new script, and it's going to be the initialize one, which is this. And this one just initializes that channel thing, which is just a string, so we initialize it as 2 quotation marks, which means a blank string. We set the first line of the debug text 0, to be just a blank line. Debug count is 0 at first, because no lines have been reported. Debug max, that's how many lines it's displayed on screen. It doesn't matter if that's more than will actually fit on the screen, because they'll just be scrolling off the top. It's just a performance thing. You don't want it to go into 5 million, because then it's having to work with a lot of strings. Debug text before last unique string. I don't know what that is. We might not need that. Debug last line is important. Debug line repeated count is important. Debug pause, that's a sort of extra feature I put in so that if there's some particular event you're watching for and things are scrolling off for some reason, you can hit a key to pause it. I can't remember what the key is. It may not be actually used, I'll probably leave that out. It hasn't been used for that many times. And debug scroll, I think that was so you could pan through the debug thing, but again, let's say optional extras, the pause system and the scrolling system are not strictly necessary. We do actually need to initialize that pause variable because we're going to reference it in our thing. Debug log initialize. That's what we'll call that. I'm going to copy that because right now we're going to put it into the create event of this. Now next we'll create the debug log script. And this one we've already explained everything that happens in here. Instead of with OCamera, I'm going to change it with OGame. And yeah, I've been through everything there, so we don't need to talk about it, I don't think. And now we don't need to call that anyway yet. We will do when we want to test it, but for now that's not something that like the game thing runs in its step event necessarily. It's only when you want to log something, you run that script. And now the final one, without which nothing happens, is debug log draw, and type that in there. That just sets up what kind of font we're going to use. Oh, the font we've selected won't be a valid one, will it? Let's look in our font thing. Let's just use F menu, I guess. And then the other problem we might have is that this value of 20 here, which is how far up we move after each line we display, that might be wrong for this font. We could do something where we kind of like we measure the height of the font. You can render some text and then measure its height. But for something like, maybe if you're making a whole menu system based on something like this, then you'd want to do that. This is just a quick and dirty debug log script. It's only going to be used in this one place. It's a unique thing. I think we'll just up that if it turns out to be too small. And yeah, I've explained what all this does. So now we just put those words in the draw event for OGame. Previously it didn't have one. It won't draw any sprites or anything. Oh, sorry, no, it's not draw, it's draw GUI, isn't it? We can change that. Draw GUI, because all those values refer to screen coordinates. Like, if we look at, I wonder where, oh, okay, so you have debug scroll reference there. So in that initialize script, I said these are optional. They're not optional. They relate to features of the script which we won't necessarily implement, but they need to be in there if you're going to copy this code verbatim because we reference it a bunch of times. If you are smart enough to understand all these things that are happening, for example, we could just remove debug scroll from there. There are ways to simplify this code to remove those features, but that's... Should we do that? In the case of debug scroll, let's do it. Let's do it for both, actually. Sorry, I'm changing my mind. We're going to remove every reference to something we're not using, because it's weird to put in code that we're not using. So debug scroll and debug pause, forget about them. Debug text before last unique string, I'm going to do a search. I don't think that's referencing there. No, it's only initialized, so we're going to forget that too. I explained what all the other things did, right? So everything here, we know what it does, we know why it's useful. And now in debug log, let's look for anywhere we've mentioned debug pause, there's one, and I'll also run a search just to make sure there's no others. There's no others. We'll never check that. And debug scroll probably won't be in here, but we can double check. Nope, not mentioned there. And then debug draw doesn't have anything about pausing. No. Okay, so that should all be clean and tidy now. And the last thing we need to do before we can test it is to actually call it from somewhere. So let's have the player. We could just have log his x coordinate or something. Or maybe speed, actually. Debug log speed. And the channel we'll use is, we'll call it player speed. Because this is a string, you could put a space in it and make it nice and neat. I tend to use join them all into one word because it means I can double click, Control C, middle click on debug log, and then double click here, Control V, and now I've switched the debug log to listen to that channel. And like I say, that channel thing is useful because we're logging speed here, and then if I decide I want to log something about the enemy, I want to be able to log something about the enemy without having to go back and delete that line of code from where I put it there. Because A, that's a big hassle, particularly if you put in like 15 different debug logs, and that's not an exaggeration, I've done that. I've done more than that to log certain errors. And then once I'm done with that, I don't have to go through and find every single one of them and remove them, unless I particularly want that code to look clean. And so it's good for that, not having to go back and remove all those things. And also, the advantage of not going back and removing those things is that often that system will break again, and then you'll need all that stuff back in there. So that was the thing that frustrated me with Unity, is I would set up all these debug logs, solve the problem, then I'd have to delete them all before I could solve any other problems to use the debug log system. And then if the original system then broke, I've got to go back and write all those debug logs all over again from scratch. There may be a way around that, maybe there's a way to use channels in Unity, but I don't care because this isn't a Unity tutorial. I'm pretty sure this is the best way to do a debug log system on Screen in GameMaker. Actually, I'm not at all sure of that, it's just the way I did it. So, is that everything? Logging our speed, set the channel. No, one more thing. We need to change our draw event, don't we? Because it refers to something called global debug. We could set up a global debug value, but I think the easier way to do it is just take that out for now. Shouldn't be complaining? No. And also debug log. Does that reference the global debug thing? It doesn't seem to. Let's search just to be sure. Global anything would be a useful thing to search for, because those are things that are in my project but not in yours. Sorry, they're in heat signature but not in this one. Okay, so let's try now. This means whenever we have a debug channel set, we will always be spewing stuff onto the screen, and that's why I have a global debug variable, and you can have one of those if you like. Yeah, font's too big. Let's change the font rather than changing the size. But yeah, when he's still, it's saying 0, and when he's not, it's saying different values. Yes, if you wanted to, if you're testing something like this, you're using a debug log, and then you decide you don't want it, then we can just set the channel to nothing, and then no text will be displayed. Actually, I didn't want to do that though, because we do want to test this. So let's create a new font. Font, don't really care what it is, size 12 is probably fine. We'll just call it fdebug. And then go straight back to the draw event and replace it in there. Let's see how that works. Yeah, it's a good job we went through this, because it's not as easy as I thought to implement this. There's loads of different things I had to strip out of that code that I had. And this way, obviously I put up the source code as ever. Hey, look at that! Oh, that's really neat. 5. Look, and this is an illustration of something I said in like episode 1, I think, where if you're going left, your speed is 5, going left, right, your speed is 5, up, down, all the speed 5. But if you go diagonally, speed is 7.07, because it's you're getting both the lateral and the vertical movement, and you shouldn't be really. But has that bothered us once in these 23 episodes? Has it fuck? It's one of those things that might bother you in code, but really doesn't have a negative effect on the game. So that's it. Oh yeah, I'll just show you that we can get rid of that stuff by just, changing the channel to nothing. Change the channel to 2 quotation marks, and now we should find that nothing is reported. When I say I'm showing you that this is true, what I'm really doing is testing that it's true, because I'm not totally sure. Yay, I'm correct. Okay, now we've got a great debug log system. We might even use that, or I might use it, particularly when I'm doing practice runs of future episodes. But that is it.